Hi, so this is A-Level Maths Tutor UK. Today's video is going to be a continuation of yesterday's video where we found the addition and the subtraction formulae for sine. This time we're going to look at the sum angle formulae or the addition subtraction formulae for cosine. So these two formulae here are the formulas that we're gonna prove today. What you'll see in your formula book is you'll see this formula here. So you'll see cos of A plus or minus B equals cos A times cos B minus or plus sine A plus, sine A times sine B. Yeah, so the important thing, I kind of mentioned this in yesterday's video, and I really recommend if you are going to watch this video, you watch yesterday's video 106 on the addition and subtraction sine formulae, the sum angle formulae for sine before this video. So the notation, the way this notation again works is that if you have a plus or minus sign there and a minus or plus sign there, it means that the A plus B, the cos of A plus B, gives rise to a negative sign there. So like the top operation there corresponds with the top operation there, and the bottom operation, the negative sign there, corresponds with the positive sign there. So that's kind of how this notation works. Yeah, so we can extend outwards, we can like pull out two formulas from this formula in the formula book. The first one, cos A plus B, is equal to cos A times cos B, take away sine A times sine B. And the second formula, cos A take away B, is equal to cos A times cos B plus sine A times sine B. So let's just do a quick reminder of the results that we got yesterday. So from the previous video, yesterday, again, I really urge you to watch that video first before today's video. So we got these results here. So when we were proving the sine formula, we showed that sine A plus B was the same as sine A cos B plus sine B cos A, and we did it using this kind of geometrical argument where we were filling in some angles, and once we filled in the angles, we were using some trig, some SOHCAHTOA to get these other lengths. So we're going to do a very similar thing with the proof of number one on this triangle here, where we've got like two right angle triangles stacked on top of each other. Sorry, let me just make my diagram a little bit smaller. So what we're going to do, instead of looking like the height of this, looking at the height of this rectangle, is we're going to focus on the width. Really, that's really what we want to look at. So let's focus on dividing this up here. So we know that we've got this right angle triangle here well, I mean, actually, if we focus on this right angle triangle up here instead, let's do that instead. So we've got, we know the height there, sine A plus B, because again, using the alternate angles, we've got an alternate angle, that angle with that angle there. So we know that this is A plus B, an angle of A plus B up there. So what we can say then is we can say that this adjacent side, given that this hypotenuse is one to remember from yesterday's video, again, I'm going to assume that you've seen yesterday's video, is that this hypotenuse there, we just call it 1. So let's call it 1. That means that this adjacent side there is going to be cos A plus B. So that's cos A plus B, like this length going from there to there. So we can also work out this length going from there to there, because we know that this is a little small right angle triangle there with an opposite side there of a hypotenuse of sine B, because again, we worked that out yesterday. So sin A is opposite over hypotenuse. So that means the opposite side here is going to be sine A times by sine B. And again, that's because, let's just make a note of this, that sine A equals opposite over the hypotenuse here of sine B. So that's why this, if I just call this opposite here, that's why this opposite side is going to be sine A times by, sorry, opposite sine A times by sine B. And again, if you want any help with how I got these lengths and all these angles, please watch yesterday's video. So we've got those lengths there. Now we can also work out the bottom length down here, because with this bottom right angle triangle right at the bottom here, we've got a hypotenuse of cos B. Again, we proved that yesterday. So this side here is the adjacent. So we've got adjacent hypotenuse, so we can use cosine. So we just call this x. So cosine of A is equal to adjacent x divided by cosine B. So therefore, that means that x must be equal to cos A times by cos B. So therefore, x equals cos A times cos B. So we know that this base, the base of this, is cos A times cos B, but we know that that is equal to this length going from there to there plus this little length there. So therefore, we can say that cos A times cos B, so cos A times cos B must be equal to cos A plus B, so cos A plus B, and then plus this sine A plus sine B, sine A. Sorry, sine A times sine B, sorry. And so trying to make, so we want to prove this first identity here. So we want to make cos A plus B subject to our formula. So therefore, that means that if we just make this, again, the writing smaller, that means that cos A plus B, because A plus B is equal to cos A times cos B, subtract sine A times sine B, by taking away this sine A times sine B from both sides of this equation there. So therefore we proved, this is proof of number one, we've proved that because using the diagram there, we've shown that this length x is cos A times cos B, and that's equal to the cos A plus B times by the sine A times sine B. So that's how we've proved that result there. So we've done the first part, that's done. So now we can look at the second part of proving cos A minus B equals cos A times cos B plus sine A times sine B. And again, we're going to use the same, a similar diagram that we did to prove the sine A minus B formula in yesterday's video. So again, this diagram here where we've got, instead of two right angled triangles stacked on each other, we've kind of got two right angled triangles matched together. So we got this one on the top and this one on the bottom here. So remember from yesterday's video, we showed that this height of this rectangle was sine A cos B. We shown that this part here was sine B cos A. And we shown that this part was sine A minus B. So we're going to do a very similar thing to what we did in this proof here. So we're going to prove number two using this diagram. So proof of two. So again, we're going to look at the widths of this rectangle and the widths on the horizontal distances. So firstly, let's think about this distance going from there to there. So we know that we've got an angle A there. We've got a hypotenuse there of cos B. So remember, with this different diagram, when we want to prove the subtraction formulae, we use again a different diagram to this one. Because in this one we call the hypotenuse 1. With this proof, what we need to do is call this middle hypotenuse 1. So we call this the hypotenuse. So, but a hypotenuse for this blue right angle triangle here in this case, therefore would be cos B. So using so we've got a hypotenuse, we've got an adjacent. If I just call this x, so we know that cos A, so cos A is adjacent, which is x, divided by hypotenuse cos B. So therefore x is equal to cos A times by cos B. Okay, so we know that. Now let's try and work out this length there. So remember again from yesterday's video, if we've got A minus B there and B here, then the total angle there is A, then therefore that angle there is A, and also therefore this angle there is A if that's a right angle there, because this is 90 minus A, angles in a triangle add up to 180, that must be 8 degrees there. So we want to find out this length there, I'll call this Y. So Y opposite, Y is the opposite to the angle A. Our hypotenuse here is sine B, so using sine, because you've got opposite and hypotenuse, that's sine. So sine A is going to be equal to our opposite Y divided by hypotenuse sine B. So therefore Y is equal to sine A times by sine B. Okay, so we have that. So we've got x, we've got y. How about the base down here? What is this base down here? Well, you've got a right angle triangle, a hypotenuse of 1, an angle of a minus b, and the adjacent side here is our base. And adjacent hypotenuse, that means cos. So we can say that this length down there, I mean, if we call this, let me try and do it in green. If we call this, let's just call it z. So cos A minus B for this right angle triangle at the bottom is adjacent z divided by hypotenuse 1. So therefore, Z was cos A minus B. Okay, so now then Z must be equal to X plus Y, because obviously the base of the triangle is, sorry, the right angle, or the sorry, the rectangle. The base here must be the same as obviously this length up there, obviously. So therefore we can just say that, yeah, so Z is equal to X plus Y. So therefore cos of A minus B is equal to X, which is cos A times cos B, subtract sine A times sine B, and that is the second formula that we needed to prove. So we proved the first one and we proved the second one. So yeah, so that's how you prove it. Again, you can use these kind of geometric triangle arguments to try and prove that. Again, you won't be asked in the exam, off the bat, prove cos A plus B is equal to cos A times cos B, take away sine A times sine B. You won't be asked that off the bat, but you may be given a diagram. You may have to like fill in parts of the diagram, or they may guide you through the proof. So that's what you could be asked in the exam. So it's just nice to know how you prove these. But yes, you are given this formula down here in the formula book, and you can extrapolate from this formula these two formulas here. So yeah, that's just a summary of how you can prove the cosine addition and subtraction formulae.